Morning guys, we're here at Queensland Gate Automation and we're going to show how to test a solar gate motor to ensure that the battery is charging. This is one of the biggest issues we face with solar gate motors, is that everything is hooked up but the technician has not checked that the battery is actually charging, or when attending a service call and the battery is flat, the question to resolve is why is it flat and why has it not charged. This is a bit of a complex testing process, so we're going to break it down into segments. First thing, we've got Alex and Clinton here from our team who are our technicians. You might have spoken to them from time to time on the phone. The tools of the trade that are essential for when testing a solar gate motor. Please do not attend a service call without at least a multimeter, which is the yellow one over there. We've used a Fluke one. It can test voltage and also current. In addition, we've got a cable current clamp. This is useful but not essential if you have and know how to use your multimeter. And lastly, we've got a battery tester, which is something that we can supply. A battery tester can measure the health of your battery as well as its charge. All right. The first thing we're going to test is the solar panel in isolation, because it is the main charging vehicle of the battery. Now you might notice Alex has been looking at the sun. This cannot be done at the end of the day. It cannot be done in cloudy conditions. It can only be done when the sun is shining. And I'm going to hand over to Alex to explain the process of testing a solar panel.
Okay, firstly, you must disconnect the solar panel from your regulator. So as you can see, it is unplugged. I have the two wires in my hand. It's essential that it is disconnected from the regulator before you start. First thing we're going to do is test the voltage coming out of the solar panel. Now on your multimeters are very different. Your one may say VDC. It may have a V with a dotted line. It's not the wavy line. The wavy line is AC. Okay, so you turn your multimeter to DC volts. Okay, and now I'm going to get Clinton to raise the solar panel up so it gets some sun, and we're going to put the two multimeter leads onto the two wires coming from the solar panel. So black on black, red on red. Now as you can see on the multimeter, we've got 21 volts coming out of the solar panel. Now I'm going to get Clinton to move the solar panel around. So move it vertically and horizontally and watch the voltage. The voltage is not going to change very much. And now what I want Clinton to do is wave his hand over the solar panel and partially shade it. So as you can see, he's partially shading the panel and the voltage is remaining the same. Okay, this is where people go wrong. They assume that if the solar panel has voltage, that it is going to work and it is going to charge effectively. This is not the case.
Guys, one of the first things we're going to do is actually confirm what type of solar panel we have, because this is something that also causes confusion. A 12-volt solar panel is required to charge one 12-volt battery. But let's have a look at what the back of this solar panel says. Clinton, could you please hold it up and just aim the sticker at me? I'll zoom in here. All right, so what we can see there is it tells us that it's a 40-watt solar panel and its output voltage is supposed to be around about 21.5 volts and up to 2.5 amps. Now this is in fact a 12-volt solar panel. Sometimes this causes confusion because the output voltage is higher than 12 volts. That is the job of the regulator, which we'll talk about later. The regulator will regulate the voltage to the correct charge for the battery. It's important to note that this solar panel will not be able to charge a 24-volt battery system or 24-volt operator. Now that we've tested the voltage, we're going to move on to the most important part of checking a solar panel to check that it's charging at the battery, and that is testing the current. I'm going to hand over to Alex now.
All right, once we have tested the voltage of the solar panel, the most important part is to test the current. The current is what charges the battery, okay? Now on your multimeter, we previously had it set to volts DC, okay, which is that setting there, which is a V with a dotted line or a VDC. We're now going to move it to the big A with the ADC, or A with a dotted line. Okay, once you put a multimeter onto amps, you do need to change the leads from the volt terminal to the amp terminal. Make sure for a solar panel test that you use the big A, which is amps and not milliamps or microamps, else you'll end up blowing the fuse of your multimeter. So we're going to switch this cable around. It's important to note just the red lead will swap over, the black lead will stay where it is.
And just a question to ask you, Alex, if you measure current while the solar panel is plugged into the regulator, so you forget to disconnect the regulator, what is the likely outcome?
You'll end up blowing the fuse in your multimeter and causing damage. So make sure that your solar panel is completely disconnected from the regulator, not wired in, okay? Now, we previously measured voltage. Now we're going to measure the short circuit current of the solar panel through the multimeter, which is done exactly the same way as the voltage is measured. So we make sure our multimeter is on amps, the lead is in the amp terminal, multimeter is on amps, and then just attach the two leads of the multimeter to the two wires coming from the solar panel, the same way we measured voltage. Now, if you note what's coming out, we're getting 2.2 amps out of the solar panel. Clinton has a solar panel aimed at around 40 to 50 degrees towards the sun. Now he's going to move the solar panel around and aim it vertically. Now watch how vertically, please. That's horizontally. Vertically, now note how the current changes with the orientation of the solar panel. It's immediately dropped from 2.2 amps in full sun to 1.7 amps facing into the sun. Now just turn it through the angles down towards horizontally. Now the more we tilt it away from the sun, the current drops. Okay, this will be the same thing if we turn it flat on the table facing the sun. So just turn it the other way around so that it faces the sun, and then just go through the full range of angles and watch how the solar panel, the current changes with the angle. So you get the maximum when the solar panel is facing around 45 degrees towards the sun. Okay, now the next thing I'd like to show you is how shade affects the solar panel. Now if the solar panel is positioned at its optimal angle, which is around 45, you're getting 2.2 amps. Now Clinton's going to wave his hand over the solar panel to simulate a leaf or a branch waving over the solar panel. So as you can see, just one hand has dropped it from 2.2 amps to around 400 milliamps. Okay, now just keep moving that around, Clinton. So it depending where the leaf or the branch is waving, it can drop it almost to zero. And this is when the solar panel is in its optimal position. Now, Clinton, can you put the solar panel flat on the table, facing upwards, and then do the same thing by waving your hand over it? So as you can see, when the solar panel is not in its optimal position, waving a branch or a leaf over it has even greater effect and completely destroys the output of current coming from the solar panel. Now, the more shade, the more it's going to degrade the output. So if this solar panel is in shade, it's not going to charge at all or sufficiently to keep the motor running.
Alex, just a question. Can we have a look at, we facing, when our solar panel's at about 45 degrees, we are currently facing, the solar panel's facing a northerly direction,
yes,
which is ideal in the southern hemisphere.
Yes.
Can we look at what happens when we move that solar panel, even keeping it in the sun? What happens when we change direction? So we've got full sun, but we are now facing east. Let's drop the current.
Yes.
And let's keep it in full sun, but let's actually turn it, if we can, to face, yes, correct, to face south.
So facing south, this is around midday, so this is getting full sun facing south. The current is 0.4 compared to 2.2 amps, which is only a quarter or less than a quarter of what it should be outputting. And if it gets shaded in this position, if Clinton waves his hand over it, it's going to drop it to a very, very low value, which is not going to be sufficient to keep your system running.
So now if we find that we have a solar panel with a good voltage reading, as we showed before, or getting around about the 20 volts, but a very poor current reading, say half an amp because of shade conditions or the angle of the solar panel, will the battery charge effectively?
The battery is not going to charge effectively. So what will happen, the battery will just keep getting lower and lower every day as the motor draws power, and it'll die after a few days.
Okay, now we're going to have a look at how you test a battery using one of the battery testers. So here we have a 12 volt battery. Alex, if you could explain.
Okay, so we're going to do a load test on this battery using a battery tester. Now we just clamp the negative lead on the negative and the positive lead on the positive. It's important that you do get a good connection to the battery. If you get a bad connection, you're going to get a bad reading. So these batteries have screw bolt terminals. Those bolt terminals must be securely fastened. If they're loose, you're going to get a bad connection. So hopefully you can see the screen of the battery tester. All right, so we're going to press enter. We're going to do a quick test. You're going to enter the amp hour rating of the battery. This is a 22 amp hour battery. So we're going to push it up to 22 amp hour. And then we're going to go test. It's going to do a load test on the battery, and it tells us that this battery is 92% healthy, 98% charged, and it is a good battery, which is the most important thing.
Now that we've tested our battery and we've tested our solar panel in isolation, we are now going to hook it up to the regulator and test that the regulator is getting the current and charging. Alex will demonstrate this using a multimeter, but we also have a smart regulator here which can also be used if one is available. Alex, over to you.
Alright, so previously we measured the short circuit current of the solar panel, which is the maximum the solar panel can provide. The actual charging current is governed by the regulator. So we're going to measure the charging current now. Now, measuring current with a system that's in use is very different to measuring the short circuit current. So what we need to do is leave your multimeter with the lead in amps, keep it on your 10 amps, but with the cable from the solar panel, you only connect one wire up to the regulator. The second wire has to go in line with the multimeter. All right, so what I'm going to do is put one of the leads of the multimeter into the regulator and screw it into that terminal. And I'm going to hold the other lead onto the cable coming from the solar panel. So the power is essentially going to flow from the solar panel through the multimeter and then into the regulator. That's how we're measuring the current. Now, as you can see, as soon as we hook it up, we are getting our maximum 2.2 amps, which is flowing into the battery. This is because the battery is a bit low and the regulator is allowing the full amount of current into the battery. Once the battery gets up to a sufficient level, this current will drop down to a trickle charge, just to keep the battery at its level so that it doesn't overcharge.
Thanks very much everyone for listening to our presentation. Hopefully this helps you diagnose solar equipment on gate motors. As I said, the biggest thing in the beginning is you must attend a site with a solar gate motor. You must have a functioning multimeter. You need to know how to measure voltage and current. As Alex demonstrated, current is probably the most important measure. Another thing that we would like to just highlight is that a lot of the regulators these days are designed for 12 or 24 volt solar panels. We are working with a 12 volt solar panel here. And in order to make sure the regulator registers this correctly, whenever connecting a regulator to a solar system, always connect the battery first. So we've connected our 12 volt battery first. That sets the regulator for 12 volt mode, and we've then connected our solar panel. So always battery first, then solar panel. Thanks for watching, guys. And if you need any further tech support, feel free to give Queensland Gate Automation a call. Thank you.
All right, we have previously measured the charging current using a multimeter. Now we're going to show you how to view the charging current through a smart regulator. All right, Clinton, if you can turn the solar panel over. All right, so if you press the left-hand button on the solar charge controller, it has other screens which will show you different information. So the first one is the temperature. This will show you the charging current coming from the solar panel into the battery. So we're just going to go back to that screen. So it's charging at 2.3 amps. It's dropping slightly. This current will change as the battery gets to full capacity. So at the moment the battery is 13.8, 13.9, 14, rising rapidly. This charging current should start stabilizing. So as you can see, the battery's reached 14.2, which is what it was set to be at. So now the charging current is going to vary. So now the regulator is pulsing the current so that it doesn't overcharge the battery. Okay, so this current is going to be all over the place now until the battery drops low again, and then that current will go to maximum. Okay, previously we showed you how to check the charging current coming from the solar panel going into the battery. Now we're going to show you how to see how much current the motor is drawing. Now if we press the button through these screens, the charging current is solar panel to battery. The next screen is the load. So this shows you what the motor controller is drawing at the moment, which is 0.2 amps load. Now, if we do a limit setup on this D5 that we have on the bench here, I'm just going to go back to that screen, load. Now, you'll see that is going to increase. I'll just go back to it again. You can see the motor's running and it's drawing 4 amps. When the motor stops, that should go down to 0.2 or something very low. If that is a large number and the motor is not running, there is a problem with the controller.